Okay, so I'm Stuart Haszeldine. Thanks for inviting me. I'm going to talk about carbon capture and storage because it's a technology which everybody reaches for. It's in the models, everybody believes it's going to happen. Is it actually going to happen or not going to happen? And I'm going to go into a little bit of detail about the technology and then try and draw out some of the principles of why it's not happening at the moment. And CCS is usually thought of as an electricity technology, but I'll also point out that it applies to the whole of the energy system, potentially to heat and to transport as well. So it's also an essential storage item if you want to do air capture. You're going to put your CO2 somewhere underground, so it applies to air capture. And of course, it's in the second half of BECCS, bioenergy with CCS, put your CO2 somewhere. So we've got a carbon production problem. We've got lots and lots of carbon underground. We're busy harvesting biomass, putting that into the atmosphere, releasing carbon from our soils, releasing carbon from rocks and industry processes and minerals. And we've produced maybe 10% of the fossil carbon underground, and that's already causing an adverse effect. So you've got this huge, giant resource underground, which under business as usual, profit-making industries will carry on putting into the atmosphere. What we also have is an ambition to clean up electricity. That's the conventional way of approaching this. Are we going to clean up electricity? Here you look at the embedded carbon in each unit of electricity, and you can see on this International Energy Agency graph that since 1990 the embedded carbon has remained persistently intransigent. We have not managed to achieve anything on decarbonising global electricity. All the renewables, all the low carbon energy is stacking up to handle the demand increase. So we're not decarbonising energy. What I say CCS is useful for, that very, very slow progress, at the moment we're heading down a track along here. What CCS is useful for is maybe not the 2 degree or 1.5 degree scenario. It will enable us to live with 6 degrees worth of emissions in a 4 degrees warming world. CCS is a long-term play, and it's a long-term survival play. To illustrate it's not just electricity, here's the UK, and a local example. CCS applies to big industry. Here's an oil refinery, petrochemical complex. Around Europe they employ 2, 4, 10 million people in high-skilled jobs, emitting lots and lots of carbon. If we take our greenhouse gas emissions for the UK, here's electricity. We've maybe done a third or a half of electricity with low carbon. Here's industry, like here, that's another quarter. Here's heat and transport, another half. We haven't started on that. And if we look at the amount of energy transmitted through the system, we've thought a bit about doing electricity. Heat is half of our energy. We haven't started on that. And to illustrate the problem of how we've not started on the problem, here's the electricity use per year, January through December in the UK. Most people working on energy spend their time on these squiggles here. Of course, if you look at the amount of energy supplied through heating in the gas supply, it's 6 times the amount of electricity in the winter. That's impossible to deliver at the moment with decarbonised energy. You're going to have to build 10 times the amount of renewables and electricity storage to do that. We haven't got an answer yet. After COP21, CCS is featuring big, and of course here's business as usual. That's the trajectory we're heading on. Efficiency is great, CCS is great, that could bring us down a little bit. Renewable heat, renewable power maybe, could bring us down a bit more. Nuclear, if you believe in that, could be a solution for part of that, but you also need, as we've heard persistently, to recapture the carbon. So some of that carbon recapture is about BECCS. I say BECCS isn't going to exist any big time anytime soon because nobody's going to plant the crops because there's no market for that. I say BECCS is probably a niche technology, and the key thing is about the sustainability, about the land use, about the replacement rate. Otherwise, you're just going to make more and more and more emissions with that biomass. And the other aspect is direct air capture. We heard a little bit about that yesterday. Direct air capture still means putting the carbon underground. You need to tackle that storage. Who pays? How do you do it? How secure is that? And it needs to be priced properly. I'm totally unconvinced that the proponents are pricing this adequately at the moment. So why do people like CCS? Well, if you're a policy person, it's good because it applies to all sectors of energy. It applies to electricity, heat, industry, and potentially to hydrogen fuel cell, especially heavy vehicles. If you're a politician, CCS provides you with lots of options, and the main option is you can carry on using fossil fuels. You carry on behaving as we have been used to behaving. You don't need to confront a lifestyle change. You believe that technology is going to be built and sort that out for you. So it's, in that sense, an easy option. And you also have some belief that you can control the rollout, and you have some belief that the market and big companies will deliver that for you, and you can make that into a profitable activity. That's not happened yet. And CCS, of course, has a big attraction in that it's arithmetically massive. If you do the arithmetic on the amount of fossil carbon, it is absolutely immense being emitted. It is a very, very secure method of storage, and once stored, it's a really low maintenance method. So it's a once and for all storage, unlike trees, for example. So here's the conceptualization of CCS. You take the fuel out of the coal or out of the gas and oil, bring that to a place where you transform that, either a petrochemical plant or a power station or a heating unit. And then you have to, that exists already, but you have to build some more kit to capture that. You have to build some more pipes to transport the CO2, and you have to build some boreholes or whatever to inject that deep underground. So there's extra stuff you need to build. That can be done, but some private companies need to know that is needed. They need assurance for investment to make a profit. People will invest if they're going to make a profit, but there is no clear ask from governments to create this industry. So there's two uncertainties there about, do we have confidence that this is needed? Will we invest in all this? Will the carbon stay down there? And how do we pay for all this? Because this is more expensive than what we're doing now. And I'll try and talk a little bit to both of those, the confidence and security and the finance. So on the security part, I'm a geologist, so I'm very happy with this. CO2 storage is a long way down, 1 kilometre, 4 kilometres down, deep, deep underground. CO2 lives in between the pore spaces of the sand grains, and there's a lid of impermeable rock on the top of that. And that will hold CO2 in there, we know, from lots and lots of natural analogues for thousands, tens of millions of years. We know exactly how to look for that type of endeavour. And to give you some idea of the size scale, here's the type of sandstone you might inject CO2 in. Of course, it's buried deep underground. These sandstones are very big. They stretch for tens of kilometres. This is the size of central London. That's a storage site you're looking for, the size of London. You can do all that. We know how to do that. That's happening around the world because CCS exists. We know how to do this. CCS for CO2 injection started in the 1970s. In the United States, people inject carbon dioxide to dry clean the rock, to dissolve the oil, to get more oil out of the rock. It's very successful. Lots and lots of oil is generated from that, or produced from that. The CO2 does not leak out. In spite of hundreds and even thousands of boreholes, there is no mass leakage of carbon dioxide. Second type of experiment or demonstration is deliberate climate mitigation. Sleipner, offshore of Norway. Norway has a carbon tax. Answer from the carbon tax, oil companies develop carbon disposal. Produce the carbon dioxide mixed in with the oil, separate it out, inject it for storage in a shallow sandstone like I've talked about there. That's been operating. 20th anniversary was last week. No leakage whatsoever. You can see exactly where the carbon dioxide is to the limit of about 100 or 100 tons. You can see that underground. It is very safe and secure. So I'll award 10 out of 10 to the oil industry for doing it for an entirely different purpose, and I'll award 10 out of 10 to the Norwegians for doing it for the right purpose. So carbon capture and storage also exists on industry. So here's an example of an oil refinery owned not by a big major oil company, but at Valero in Texas. And on this site here, you make hydrogen from splitting methane, carbon and hydrogen and methane split into hydrogen because you then make higher value products with that hydrogen. That's the separation unit. That's relatively tiny. Separation units on power stations are planned to be about the size of Keble College. This is better technology. Okay, better technology exists, it's creeping in. Most developers are locked into 1930s, 1950s technology. So the technology exists, it needs to be pulled through. This is capturing 1 million tons a year, initially by a Department of Energy funded project in the United States. And it's been so successful that the company's now built a second one off its own money. So it can exist, and given the right market, that can work profitably. So this is good. This works. 9 out of 10. What if it leaks? Nightmare scenario. Anybody who's not a geologist tells me it's going to leak and explode in a ball of flame. It clearly doesn't. Here in Green River in Colorado Plateau, the Americans drilled for oil in the 1930s and found carbon dioxide. That well leaks carbon dioxide. It's a cold geyser. It erupts once or twice a day, and there's nothing else to do in Green River, so tourists come and have a look at it. You can see they're not dead. Okay? In Rome, here's the EasyJet plane coming into Rome, because I'm a cheapskate on EasyJet. Here's the football pitch, here's southeastern Rome suburbs. Here's a natural leak of carbon dioxide which has existed since people ever colonised there. That's right next to where everybody lives. As long as you don't go there and lie down, you're not dead. Here's the biggest leak of carbon dioxide in Europe, also in Italy. That's the equivalent of a natural carbon dioxide leakage, equivalent to a gas-fueled power station. Don't go into that bit because the carbon dioxide lies densely in the valley, but it just goes away, dilutes and disperses, mixes into the atmosphere. It's not a good idea to do that. It's a natural thing. It's unfenced. Nobody looks after it, but it's not a huge problem. In Italy, they've diligently recorded the number of, they have 300 natural carbon dioxide seeps, diligently recorded the human deaths by people doing crazy things like going to lie down next to the carbon dioxide. 19 deaths in 50 years, that's a fatality risk of 1 in 36 million, which is 36 times better than the safety standard for disposing of nuclear waste. Okay, so unregulated, widespread carbon dioxide leakage, no fences, maximum fatalities, not a problem. CCS is just starting. So we're at the transition stage. We're at the step change between old burning technology and slightly more modern technology. We are here at that first episode of more modern technology. Eventually, we may get to something we don't know yet. But we are here, we are able to develop carbon capture and storage. There is no technical reason to stop, to delay. CCS will improve. Actually, I'll say, somebody talked about wasted years. We could have done this in 1995. We could have done it in the UK in 2005. Because of political and market inertia and lack of signals to companies to invest, we're wasting time. Here's the build rates. This is a compilation by Shell of all sorts of different energy technologies, ranging from oil, nuclear, biofuels, wind, solar, photovoltaic. CCS is here. This is a graph published in 2009, so we have to change the timescale on the bottom. CCS is just starting off, so we have to change the timescale to add 15 or 20 years on that. But what happens, and Michael Grubb talked about this this morning, the usual way a technology develops is a slow investment and then everybody piles in and then you achieve nirvana. So we're here. If we want this to go fast, you have to invest more at the beginning and go up that curve faster. But the other point is, with any of these technologies, this takes about 40 years to materiality, to get 10% of the global market. Materiality is very important to be significant. So we're ready to go in the UK. Case study of the UK. I've got about 4 more slides, actually. So we've done all the background bits, the legal, the regulation, the science and technology. The missing bit is the business. And the business bit is missing the politics. And the politics is not giving anybody any confidence. So how do we do this? There's a consortium of oil companies claim that they have 20% of oil and gas production. They've been talking to each other since 2014, and it would help me at least to have some confidence that they're actually going to do something. If they own 20% of production, they're catalysing critical action on climate change. Well, let's see it. A different way of doing that, government policy levers. So people are very keen on a carbon tax. We've been charging tax in the UK on oil production since 1980. We've netted 300 billion UK pounds on taxing oil production, and we've spent about 200 million on climate mitigation of carbon. So the problem is that the resource is produced, the government takes the money, and the government spends it on all sorts of other stuff. There is no feedback loop. If you're dealing in money and tax, you can't trust the government to spend the money on what we would like it to spend the money on. You need a different lever. And so my question is for government, read the question. 2 out of 10 for trying, but nothing on succeeding. And basically, I think you need to have a lever which says if we want carbon dioxide to be stored, we have to have a law which says store carbon dioxide. So if you produce carbon dioxide, we'll give you a certificate free of charge. If you don't store carbon dioxide and discharge the certificate, we charge you lots and lots of money. I'm running out of time, so we're not going to dwell on this. Oxborough report out in the UK last week is basically trying to say, here's a way we can actually marketise this. The government has to set the rules so investors can invest and make this system work. There's no way the government can fund this and support this because it's too big. If we work this correctly, last slide, this is how much carbon dioxide one gas-fueled power plant would accumulate every hour. This is obviously central London for people who don't know. And CCS exists. We were 2 weeks away last year from getting developments sanctioned in the UK. CCS exists. It can be safe. It can be secure. I argue it starts better with industry. You have to make the oil companies do it. It's essential action. It's not perfect. And with luck, if we do this, then you'll see the pot of gold on the plinth at the end of the rainbow.